The story of plate tectonics after Wegener's death. So the year is 1914 and we are in the midst of World War I. Submarine use is becoming common. What can we do? How do we fight this? With this new technology of submarines, we had to have a way to know that there was a submarine coming. So in order to detect submarines, a new system was developed. It was called sonar. Now sonar is basically sound waves. The sound waves were sent through the ocean and they would bounce back off of a solid substance. In this instance, they would bounce back off of a submarine. This allowed the Navy to detect when a German submarine was approaching. Now, during World War I, it really was too new, but it really became popular to use during World War II. Now, at the time, it was still being used to detect underwater activity, but a side effect of that was it was also used to map out the ocean. Up to this point, people had not really thought much about the bottom of the ocean. They just assumed it was flat, just like a beach. So if you go to the beach, you see the waves come up and they kind of flatten the sand. Well, that's what the scientists thought the bottom of the deep ocean was like, but they were wrong. So along came Harry Hess. Now, Harry Hess was a geology professor, so he was studying the Earth. It's kind of funny that he says when he first started studying geology in college, he failed his first test and his professors told him he needed to find a new profession. But he continued his pursuit and he became a professor of geology. Now, he was also in the Naval Reserves. So after the bombing of Pearl Harbor, he was activated. So he went from teaching geology to working on naval ships. And he was actually one of the guys that was manning the sonar devices to help map out that ocean. So what he discovered was really eye-opening to many scientists at the time. So remember I said they thought the ocean floor was flat. Well, what he discovered were underwater mountains. They were flat-top mountains, but they were very high underwater mountains. So he, as a geologist, became very interested in these underwater mountains. So they came up with the term mid-ocean ridges. Now, the underwater mountain ranges are divided, so they run side by side. Some of them are just continuous, the largest being in the Atlantic Ocean. So when we look at these underwater mountains, at these mid-ocean ridges, they look to see what was actually happening there. And you see magma is rising to the surface. So Hess proposed the idea of seafloor spreading. So with seafloor spreading, what's happening is the magma is rising to the surface and is hardening as it hits that cold ocean water. It pushes the older crust to the side and creates new crust. So you see in this picture where we have the red indicates the young crust and the dark blue indicates the oldest crust. So it's being pushed aside. So with this development of seafloor spreading, scientists were really intrigued by the movement of the Earth and this creation of crust. They decided Alfred Wegener was right. The continents were moving. We now have evidence of this movement. So the idea of continental drift came back. So what scientists further discovered was that the Earth is broken into plates. So the lithosphere, the very tip top of the mantle and the crust together, is broken into these tectonic plates. Where any two plates meet is called a plate boundary. Now, it's a little bit different than what Alfred Wegener thought. Alfred Wegener thought, remember, that the continents were floating. Well, that's not true. There's actually continental crust and oceanic crust, and both are in motion. So the ocean floor is in motion along with the continents. So that was a slight flaw in his original theory of continental drift. Soon more evidence was discovered. Remember, we have more technology now. So there was more evidence being discovered in the form of mapping locations. They looked at where we found earthquakes and volcanoes. And if you look at this map, the red triangles indicates a volcano and the blue dot indicates an earthquake. If you look closely, they line up on the plate boundaries. So scientists conclude there's a lot of movement and activity at those plate boundaries. you're more likely to find a volcano or an earthquake taking place where two plates meet. So if we look at this new evidence, so this is evidence that came about after Alfred Wegener, the discovery that there were underwater mountains, those mid-ocean ridges, which led to the discovery of seafloor spreading, where new crust is being created, pushing older crust away. So there was movement on the seafloor. We looked, there's a lot of movement at the boundaries. That's where we find earthquakes, and that's where we find volcanic activity. All of this together really was emphasizing continental drift. But we were still missing that piece. Remember, Alfred Wegener couldn't answer how this could happen. So without knowing that, we still didn't have a different theory. We're still working with that theory of continental drift. So what is causing the plates to move? What's causing seafloor spreading? We now know it's convection currents. So you studied convection currents in 6th grade. Well, these convection currents are taking place inside the Earth. They're taking place inside what's called the asthenosphere, which sits directly below the lithosphere, where those plates are. So in the asthenosphere, the rock is softened and it's going to flow. It flows because of the heat from the core of the Earth. So the core is the hottest part. That heat rises and it causes the melting of rock, which would create magma, but it also causes rock to soften. Now, you see how it is moving. This is causing the plates to move. The convection currents are dragging the plates with them. So those tectonic plates are going to move in whatever direction the convection current is moving. With this new idea, we have the how. How did the plates move? We now have the theory of plate tectonics. So remember, the theory of plate tectonics, we know that the Earth, specifically the lithosphere, is broken into the tectonic plates. We know that convection currents in the asthenosphere are causing the plates to move. The movement of those plates is creating different landforms, such as mountains, ridges, volcanoes, faults. And we know that it's not just the continents moving, it is the continental and oceanic crust that move together. So the theory of plate tectonics is a little bit different than the theory of continental drift. So remember, Alfred Wegener thought that the continents just floated away, but he couldn't explain how. The theory of plate tectonics states that the oceanic and continental crust are moving, and we know it's moving because of the convection currents in the asthenosphere. So scientists now agree that Alfred Wegener wasn't as crazy as we originally thought.
There was a scientist whose name was Alfred Wegener. He noticed that the continents looked just like pieces of a broken puzzle. By 1915 he called it continental drift. It caused a rift with his fellow scientists who sang, ha ha, Alfred Wegener, you are a crazy man. Ha ha, Alfred Wegener, you are a crazy little man. They reminded him he had no proof for how or why the continents could do this. And until you show just how or why, you merely have one interesting hypothesis. Until this evidence we see, you don't have a theory. Ha ha, Alfred Wegener, you are a crazy man. Ha ha, Alfred Wegener, you are a crazy little man. In the year of 1930, on an expedition to Greenland, Wegener got caught in a blizzard. When they finally found him, it was much too late, and they buried him in an icy mausoleum. after he died, a new idea came to light. It changed the way geologists saw the world and brought continental drift back to life. Now everybody sings.